My dear students, very good afternoon. Today in this class, we are going to deal halides in detail. In the last class, we have dealt halides, halogens. What is the symbol for halogens? X. Halogens are represented with the symbol X. Whereas if there is a minus charge or negative charge on halogen atom or halogen element, we name it as halides. See here, X is nothing but halogens. These halogens are fluorine, chlorine, bromine, iodine, astatine, and so on. Here, these halogens are present in the 17th group of the periodic table. If I place a minus charge on this fluorine, that is F minus, that is fluoride ion. Next, Cl minus is chloride ion. Bromide ion, Br minus is bromide ion. I minus is iodide ion. In the same way, you can name the remaining. Here in the textbook, they have given you one example. They have given you one example, that is 1 bromo butane. They have taken 1 bromo butane. Here, as you know already, bromine is the halogen group, butane is the parent chain. Here the parent chain has 4 carbons. Here it is indicating beta, so it has 4 carbons. A means single bonded compounds. So this is the structure which is written for this given IUPAC name. For this IUPAC name, this is the structure. Similarly, here for these halogens, the prefix which is used is haloalkane. Haloalkane is the prefix which is used while writing the IUPAC nomenclature, IUPAC naming. In order to write the IUPAC name for the halogen compounds, you need to remember this general name, haloalkane. So here, what is halo? Halo, what is the halogen which we have taken? Bromine. So halo means bromo. Alkane, here we have taken is butane. So alkane is the butane. Next we will discuss about halogens in detail. See, here halogens are represented with the symbol X. These are present in the 17th group of the periodic table. 17th group of the periodic table. Here these halogens already we have discussed while naming the IUPAC. While naming the IUPAC name, we are using the prefix haloalkane. We are using the prefix haloalkane. This for IUPAC system. Common name or general name or trivial names. This is the trivial names. Here we are using alkyl halide. We have to use the general name as alkyl halides. Alkyl halides. For this, I will take one example, that is 2 bromo pentane. 2 bromo pentane. See here, in order to write the structure for this given, this is the IUPAC name. Already IUPAC name is given. For this, I am going to write down the structure. See here, bromo, that means bromine is present. Parent chain is having 5 carbon atoms and A single bonded compounds. So here you take pentane. First you draw the chain, carbon chain, 2, 3, 4, 5. You place the bonds here, then you number the carbon atoms 2, 3, 4 and 5. At C2, see here 2 bromo, that means bromine is present at second position. Second carbon atom, so 2 bromo pentane. Now you have to satisfy the valence of carbon atom with hydrogens, CH3, because one bond is there, already one bond is there, so it needs 3 more hydrogens. Here 1, 2, 3, so CH, here CH2, CH2, CH3, 3 plus 1, 4. So totally there are 4 carbon atoms, okay, with bromine group at C2 position, at C2 carbon atom. So this is the structure for the given IUPAC name for 2-bromopentane. Now here I told you common name or general name or trivial name. What is the general? Generally it is taken in this form, alkyl halide. Here what is the alkyl group? Here the alkyl group must be pentyl. This is pentane, so we have to take in the form of alkyls. This will become pentyl. Pentyl. Bromine. This is the halide. This is the halide. So bromine. We should take this as bromine. Pentyl bromine. I'll write here the common name for this given structure is pentyl bromine. Pentyl bromine. The common name for this is in the form of alkyl. This pentyl is nothing but alkyl, and this is nothing but halide. And then see here, you have to convert this into ide form. This will become pentyl bromide. Pentyl bromide. And then now we go to the classification of haloalkanes. We go to the classification of these halogens, that is haloalkanes. We go to the classification of haloalkanes. See here, haloalkanes are classified differently based on different conditions. Here you can see the first category. These haloalkanes are classified into on the basis of number of halogen atoms. On the basis of number of halogen atoms, they can be monohalogen derivatives, or dihalogen derivatives, or trihalogen derivatives. Monohalogen or dihalogen derivatives or trihalogen derivatives. So this is based on the number of halogen atoms which are attached to the carbon atom. Monohalogen is nothing but, you can take, see here, under this you can take, see here, only one halogen is present. This will come under monohalogen derivative. Okay, and for dihalogen, this is 1, this is 2, this is 3. So for second one, here you can take one more. If you are taking one more, this will become dihalogen derivative. If you are taking 3 halogen groups, it will become trihalogen derivatives. Okay, so depending upon the number of the halogen atoms which you are taking, it will be termed as monohalogen or dihalogen or trihalogen haloalkanes. And then if you see, so this will come under, all this will come under aliphatic, because there are no benzene rings. Here. If you are having benzene rings, what would be the structures? Here you see, the structures will become, you have to take the benzene ring like this and you attach the halogen group. See here, halogen group is bonded to the benzene ring. When the halogen group is bonded to the benzene ring, okay, these are called as, in aromatic compounds, these are called as haloarenes. This is halogen group and this is the arene group. Arene group is nothing but benzene group. So here only one halogen is attached to the benzene ring. If there is one halogen, this haloarenes are of three types: mono haloarenes, dihaloarenes. Similarly, the last one is trihalo or polyhalo, tri or polyhaloarenes. See, this is dihaloarene, trihaloarene. This will be the tri or polyhaloarenes. See here, arenes are nothing but benzene rings. These are the aromatic rings. This will be the aromatic rings. So here the classification, once again I will explain you the classification of halogen compounds. Here classification of haloalkanes on the basis of number of halogen atoms. On the basis of number of halogen atoms, these are divided into monohalogen. These are divided into monohalogen derivatives, dihalogen derivatives, trihalogen derivatives. Here you can see if one halogen is connected or bonded to the carbon atom, it will be termed as monohalogen derivative. If there are two, it will be termed as dihalogen derivative. If there are three or more, tri or polyhalogen derivatives. So these are aliphatic compounds. Similarly, you can take aromatic halogen compounds. See here. So these are the aromatic compounds which are having the halogen groups bonded to the aromatic ring. These halogens are bonded to the aromatic carbon atoms of the aromatic ring. This is the monohaloarene, dihaloarene, trihaloarene or polyhaloarenes. Next, this is the first class of compound. Till here we have finished the first class of compound. Second class, this is the important class of compound. Second class of compound is nothing but haloalkanes. These haloalkanes are classified based on the nature of carbon atoms. Nature of carbon atom. Haloalkanes are classified based on the nature of the carbon atom. See here, carbon atoms are divided into primary carbon atom, secondary carbon atom and tertiary carbon atom. What is primary, what is secondary and what is tertiary? See here, I am going to take the structures in order to understand what is primary, secondary and tertiary. 1, 2, 3. Here I am bonding halogen atom to the carbon atoms. See here, the carbon which is bonded to the halogen atom should contain one carbon atom directly. Bonded carbon atom is 1. To this carbon, the carbon atom which is connected or bonded to the halogen atom must contain only one directly attached carbon atom. So this carbon atom will be considered as primary alkyl halide. See here, this is the alkyl group, this is the alkyl chain, this is the alkyl chain. How many carbons are there? 3. So it will be propyl. 3 carbons are there. So what is the type of alkyl group present here? Propyl. Propyl is the alkyl group, propyl. And then halogen is there. So propyl halide. The name is propyl halide. So the type, what is the nature of the carbon atom present in this organic compound? Primary alkyl halide. So what is the type of alkyl halide? This is the primary alkyl halide. That means The carbon atom which is bonded to the halogen must have one carbon which is directly attached. Here if you see the second, so this is the primary alkyl halide. This is the primary alkyl halide. Now if you go to the second one, this is one example, this is the other example. See here I am going to take, here again I am placing the halogen atom, I am bonding the halogen atom. See, this carbon must possess, if it is possessing only one, it is primary. If it is attached to one more carbon, if it is attached to one more carbon, see here the carbon which is directly bonded to halogen atom must possess two directly connected, two carbon atoms which are directly connected or bonded. This carbon atom will be said as secondary alkyl halide. This is secondary alkyl halide. Secondary alkyl halide. This is the second. See, for tertiary alkyl, what is the tertiary? Carbon having halogen atom must have three carbons which are directly attached to the carbon which is having halogen atom. Now see here, you can satisfy the valencies of all the carbon atoms. You can satisfy the valencies of all the carbon atoms with the hydrogens. Okay. Here also you can satisfy the valencies with hydrogen atoms. Here also you can satisfy with the hydrogen atoms. Okay. So this carbon you can say either as carbon directly attached with carbon or alkyls. So here you can name this as tertiary alkyl halide. This is the tertiary alkyl halide. Okay. So this concept is based on the nature. This concept is based on the nature of the carbon atom. That is primary. If the carbon is primary, because it is coming under halogens. Halogens we are taking it as primary alkyl halide, because halogen groups we are talking about halogens. So primary the nature of the carbon is primary. We are talking about halogens, so we are naming it as primary alkyl halide, secondary alkyl halide, tertiary alkyl halide. So this is the second classification of haloalkanes. It is based on the nature of carbon atoms. Next one, we go to the next classification. We go to the next classification. Third classification. We have finished two classifications. Now we will discuss about the third classification of haloalkanes. This is based on the hybridization. Based on the hybridization of the carbon atom. Hybridization of the carbon atom, to which halogen group is bonded. To which the halogen group is bonded. Here you can see I'll take an example here. Here you see the example here. This is one example and this is the other example. This is one example and this is the other example. Here halogen is attached to the carbon. Here carbons are present. At each point carbons are present. Here carbon is there. Here one carbon is there. Here one carbon is there. Here one carbon is there. Okay. So these carbons, halogen when it attached to the carbon, attached to the, this carbon is, what is the hybridization of this carbon? sp2. sp2. This is the sp2 hybridized carbon. And what is this? This is also sp2 hybridized carbon. But whereas this carbon, see here, this carbon is sp3. This carbon is sp3 hybridized carbon. Here when halogen is bonded to sp2 hybridized carbon, when halogen is bonded to sp2 hybridized carbon, these haloalkanes are called as vinylic halides. These are called as vinylic halides. Vinyl is nothing but two carbons having double bond and one linkage. Okay, this is CH2 double bond C and one linkage So this group is called as vinyl. Whereas allyl is nothing but it has three carbons with one double bond. Three carbons with one double bond is nothing but and one linkage. Here you can see three carbon atoms with one double bond and one linkage. Here this is nothing but allylic linkage. This is vinyl group, vinylic linkage. Here any group you can take any group. You can take any groups, halogens or alkyl groups or whatever you want, or functional groups. You can take any other groups. Okay. Here halogen is bonded to the sp2 hybridized carbon. This will be considered as vinylic halide. These halides are considered as vinylic halides. Whereas here if you observe the structure here, halogen atom is bonded to the carbon atom which is sp3 hybridized. Such halogen derivatives, such haloalkanes are called as allylic. These are allylic halides. These halides are called as allylic halides. So the difference between vinylic halide and the allylic halide is nothing but vinylic halides, the halogen group is attached or bonded to the sp2 hybridized carbon, whereas in allylic halides the halogen group or halogen atom will be bonded to the sp3 hybridized carbon. So this is allylic halide and this is vinylic halide. This is the third category of haloalkanes. Haloalkanes are also called as alkyl halides. These are also called as alkyl halides. The fourth category. Now we go to the fourth category. Fourth category of haloalkanes is nothing but benzyl halides. Benzyl halides. Here you see benzyl. The structure for benzyl is it will have benzene ring along with one CH2 group. So this is the benzyl group. This is the benzyl group. Benzyl, that means benzene with one CH2 group. Here you can have substituent, any other group. Suppose if you are taking X as Cl. Suppose here you are taking X is equal to Cl. The structure will become again you take the ring, connect CH2 and then Cl. See here, already we know till here the name of this particular compound is benzyl. Chlorine is there. So you can name this compound as benzyl fluoride. So this is benzyl fluoride. Okay. So generally these are called as benzyl fluoride. You can take any other halogen. Fluorine, bromine or iodine you can take. If fluorine is here, benzyl fluoride, benzyl bromide, benzyl iodide and so on. So here these are generally called as these benzyl fluorides or these benzyl fluorides are generally called as benzyl halides. This is the fourth category of haloalkanes. Next, coming to the fifth category, aryl halides. These are aryl halides. Aryl is nothing but benzene groups. Aryl are nothing but benzene. See here, this is the benzene ring. I am bonding halogen group. Here you see, if you write this structure in the form of bonds by taking bonds, I am connecting halogen here. See here, what is the type of carbon atom? What is the hybridization of the carbon atom to which halogen is attached? This is the carbon atom. Now this carbon atom is sp2. This is sp2 hybridized carbon atom. This carbon atom is sp2 hybridized carbon atom. So the linkage, see, already I have explained you the type of linkage is nothing but, see, in the before previous, just I have explained you, this is a vinylic linkage. So what is the type of linkage here? Vinylic. So here we can see the vinylic linkage. Vinylic linkage, that means vinyl halide is present here. Vinyl halide is present here. And then, so these are the total classification for the haloalkanes. Next, we go to some questions. We will go to solve some questions. Here the question is, I am taking the benzene ring. To this I am connecting here groups. I am connecting the groups, and here halogen. This is alkyl 1, alkyl 2 and halogen. If R dash is methyl and R double dash is hydrogen, R double dash is hydrogen, what is the nature? What is the type of alkyl halide or aryl halide? You can name, benzene ring is there. So what is the nature of carbon atom? What is the nature of carbon atom? Here, see, if R dash is methyl, R double dash is hydrogen. See here, I'll write this structure here. I am taking the benzene structure. I am taking R dash. As I have said, R dash is methyl, so I am taking methyl. Then R double dash is hydrogen. Halogen is present here. So here you see, here carbon atom is there. This point is nothing but carbon. This carbon which is attached to the halogen group, already I told you what is primary, what is secondary and what is tertiary. So based on that concept, the carbon which is bearing halogen atom, if it is having one alkyl group, directly one alkyl group which is attached, that will be considered as, see here, not only one carbon is directly attached to this, another carbon is also there which is present in the ring. So the carbon atom which is bonded to the halogen atom is directly having two carbon atoms. This is both two carbon atoms are directly connected to the or directly bonded to the carbon atom which is bearing halogen. So this carbon will be said as secondary. This will be secondary. Okay, nature of the carbon atom is secondary carbon atom. This is the secondary carbon atom. This is the first one. If R1 and R2 both are methyl groups, if both are methyl groups, what will be the nature of carbon atom? I am substituting the groups here. R dash methyl, R double dash is also methyl, and here X. This is the carbon. You already know that this point is the carbon. See here, the carbon atom which is bearing halogen atom is having 3. This is the 1, this is 2 and this is 3. So this carbon atom is having 3 carbons which are directly bonded to this carbon. So this carbon is having 3 carbons, okay, which are directly bonded to the carbon which is having halogen group. So this will be termed as tertiary carbon atom. This will be the tertiary carbon atom. Okay, so this is the question. If they are giving you the question like this, what is the nature of the carbon atom, you should try to solve. You should try to solve like this. You take and then these groups you substitute in the given general formula and then you try to solve the nature of the carbon atom. This is secondary because the carbon which is bonded to the halogen is having two carbon atoms which are directly attached. Here there are three carbon atoms which are directly attached or directly bonded to the carbon atom bearing halogen. So this is the tertiary carbon atom. The last question, see here, in this I am going to give you the last question. Identify primary, secondary and tertiary haloalkanes from the given below structures. From the given below structures. See here, dear students, please try to solve CH3Cl. Second one is CH3 C bond CH3, here also one bond CH3, here Br. The third one is CH3 CH2 CH3, here one bromine group is attached. Now you try to solve this question. Students, first you should clearly understand the basic concepts. Okay, no need to worry, no need to hurry. First you should understand the concepts very clearly, then you keep going on solving the questions which are given in your textbook. Then slowly finally you have to refer the previous year's NEET question papers or JEE mains. So first and the most important thing is you should be thorough solving the problems or whatever the questions which are given in your textbook, in the exercise questions or in the which are given as in text questions, and the questions which are given in the at the end of the chapter. So first you should solve the questions which are given in your textbook, then you should go to the questions which are given in the previous papers. So you should, it is compulsory if you want to score more marks in any exam, it may be IP or competitive exams, you should first learn the basics from the textbook and then you go to the previous question papers. It will be easily available, okay, and then you try to solve each and every question. Okay, dear students, thank you very much.